Hello, Coach Travis here with another calculus video. So we've got a definite integral here. So it wants us to evaluate, this question is asking us to evaluate this definite integral. So integral from 2 to 12 of f of x, and this is the graph of f of x. Okay, so the way we want to do this is remember that the definite integral of a function is the area under the curve. Well, actually that's not quite true. It's the signed area under the curve. So because of the way the definite integral is defined, area that's below the x-axis gets counted negatively by the integral. So it's kind of annoying, but hey, you know, that happens sometimes. If you want to, you can write your own calculus book and you can define the integral differently if you want to. That would be a fun summer project. But for many reasons, the current definition of the integral that we have is great. It just has little annoying facts that it doesn't actually give you the area. If the curve ever dips below the x-axis, it won't actually give you the area, but it does the next best thing. Okay, so again, what do I mean? Yeah, so let's get serious. Let's do this. Okay, so so we want x to range from 2 to 12. Okay, so well, there's 2. And there's 12. Okay, so basically it just wants me to consider the whole picture. So alright, so what I'm going to do is I'm going to find the areas of each of these pieces. And so let me think about this. Let's do this piece first. Maybe I guess I'll shade it a little bit here. This triangular piece right here. So it's a triangle. And so the area is base times 1/2 base times height. So the base you can see is 4, and the height is 3. And 3 times 4 makes 12, and 1/2 of 12 is 6. So the area of this little triangle is 6. All right. And now let's move over to this piece. Okay, so this is a trapezoid, and so there are formulas for finding the area of a trapezoid, but honestly, I never remember them. So if you remember it, good for you. Well, actually, I do remember it, but I'm just going to do it piece by piece here. I can see that, okay, there's a triangle there, there's a rectangle here, and there's a triangle there. And so this triangle has a base of 2 and a height of 4, which means the area of that triangle is 4. And this triangle is basically the same thing. So that has an area of 4. And then this is a 2 by 4 rectangle. And so this has area 8. So, okay, so what does that mean about this integral? So this integral, the way the integral works is it's the signed area. So that means that area above the x-axis gets counted positively. So we have 16 area that gets counted positively. But then we have a 6 area, but that's below the x-axis. So area that's below the x-axis, the integral counts as a negative number. So our final answer here is going to be 10. So the idea is your definite integral is the signed area under the curve, and so area above the x-axis gets counted positively. Area above the x-axis gets counted positively, and area below the x-axis gets counted negatively. So again, it's all about areas. You just have to be a little bit careful about, is the area above the x-axis or is the area below the x-axis? But not really a big deal.